In this section, I am going to discuss about overhead line insulator. In that, what are the various factors influencing the selection of line supports, and what is cross arm and the necessity of the cross arm and various types of cross arms. What is pole guy and necessity of the pole guy, and definition of the overhead line insulator, and the purpose of the insulator and various requirements of the insulator. So first we will go for the factors influencing the selection of line supports. Last class we are discussed for the line supports are classified for 5 types, that is wooden pole, steel pole, reinforced cement concrete pole, pre-stressed cement concrete pole, and then towers. Here, what are the various factors influencing the selection of line support? The first one is the span length of the power line. Actually, the last class we had discussed, for wooden pole, the span length is less than 50 meter. For steel pole, the span length is 50 to 80 meter. For RCC pole, the span length is 80 to 200 meter. And pre-stressed cement concrete pole, the span length is 80 to 150 meter. And towers, that is unlimited span length. That is, it can be used for up to 500 meter also. Based upon the span length, we can choose for the which the supporting structure is required in the towers. And the another one, cross sectional area of the conductor. How much the cross sectional area? Based upon the cross section, the required for poles or towers. Next one, transmission line voltage. Up to 33 kV, we are preferred for the poles. Beyond 33 kV, we are preferred for the towers. That is, again in the tower, based upon the operating voltage, structure it should be different. For 132 kV, the structure is different. For 220 kV, 400, and then 765 kV, the structure is different. That is the transmission line voltage. For transmission line voltage, if the operating voltage is single phase 230 volt, they will be go for the PSCC pole, that is pre-stressed cement concrete pole. That is 3-phase 4-wire system. At the time, they will be go for the RCC pole, reinforced cement concrete pole. Span length and then the transmission line voltage, it is the major parameter for selecting the line supports. And cost of the line, we are choosing the line, the cost it should be minimum and based upon the area. Suppose if the cities and town, there the industrial consumers are there, they are preferred for the RCC pole for distribution purpose. That is, the villages only few consumers are there, only 5 consumer or 10 consumer. At that particular places, they will be preferred for either wooden pole or steel pole or PSCC pole. That is cost of the particular line. And the local site condition. In that the particular area, we need to measure for how much the wind velocity and ice and falling, etc. That is, some of the open atmospheric condition, the wind velocity is more. For the particular places, we need to prefer for 33 kV also preferred for the towers. And if hilly area or in that river crossing or lake, that is in that particular places, the ice falling is more. That is, we need to observe in the particular area what is the local site condition, that is the wind velocity and the ice falling. And number of necessary parts required, that is cross arms, insulator, bolt nut, so on, etc. That is the stay wire, pole bow, pole guy, so on, etc. And type of maintenance is required, that is regular maintenance or the annual maintenance or 3-year or 5-year maintenance. If you erect for the steel pole, we need to visit for the regularly, that is regular painting, every twice year once or every 3-year once. If you erected for the wooden pole, every 3 months once we need to inspect for the visiting. That is types of required. These are the various factors influencing the selection of site for line supports. And the next one, need for cross arm. What is the necessity of the cross arm? The main function of cross arm is to keep the conductor at a safe distance from each other as well as from the pole. Now, these cross arms, it is used for both poles as well as for the tower. For example, you can take, this is the pole, RCC pole. For example, you can take the operating voltage in the line is 11 kV. Here, less than the 1 feet or 1.5 feet, they are fixed for the cross arms. That is, in this the cross arms, the fitting of the insulator and top of the insulator groove they are taken for the conductor. The top of the insulator groove they are taken for the conductor. For example, we can take this is R phase, Y phase, another one is for the B phase. What is the need or what is the necessity of the cross arm? It is to keep the conductor at a safe distance from each other as well as from the pole. From starting point to up to the receiving point, the distance it should be maintained for same. And another one, suppose due to the wind pressure, if it is not maintained for the same distance, the conductors are close to each other, the short circuit is appeared. To avoid that one, we are used for the cross arms. In overhead line transmission line system, the conductors are run on the line supports. If the conductors are not placed sufficient spacing, causes the air between conductor gets ionized and hence the short circuit may be appeared. The purpose or the main function of the cross arm to avoid conductor clashing due to windage. To avoid conductor clashing due to windage. Generally, in the rainy season, high wind pressure is there. At that time, the conductors are close to each other. To avoid that one, we are used for the cross arms. And the types of cross arms, it is classed for 4 types: MS channel cross arm, U-shaped cross arm, V-shaped cross arm, and then zigzag cross. This is the MS channel cross arm. Here, this is the supporting structure they are used for either wooden pole, steel pole, RCC pole, or PSCC pole. Here you can observe, here they are given for the 1.5 feet downwards. They are fixed for the cross arms with the help of clamp and then bolt nut. With the help of the clamp and then bolt nut. Here they are fitted for the insulator. In top of the groove of the insulator, they are taken for the conductors. They are taken for the conductors. That is, they are used for single phase 2-wire system or 3-phase 3-wire and then 4-wire system. Another one, U-shaped cross arms. U-shaped cross arms. That is, the cross arm, the shape is called as the U shape. That's why it is represented for the U-shaped cross arms. Here also, these the cross arms fitted in the supporting structure, that is poles, with the help of clamp and then bolt nut. With the help of clamp and then bolt nut. Here the conductor they are taken fixing of the insulator. The top of the insulator groove they are taken for the conductors. And the third one is V-shaped cross arms. This is the maximum they will be preferred for the transmission purpose. The transmission as well as for the distribution purpose. For 11 kV and then 33 kV overhead line, they are taken for the V-shaped cross arms. That is 3-phase 3-wire system. Here they are taken for the conductor 1, conductor 2, another one is for the conductor 3. That is R phase, Y phase, another one is for the B phase. Here the shape is represented in the form of V shape. That's why it is represented for V-shaped cross arms. In this, the cross arms they are fitted for the insulator with the help of bolt nut, and the top of the insulator groove they are taken for the conductor. And these the conductor should be maintained from one pole to another pole, or the starting point to up to the ending point or receiving point. The spacing it should be maintained for the same. That is R phase to Y phase and Y phase to B phase as per the IEEE standard. And the last one is zigzag cross arm. Wherever the dead zone, wherever the cross section is there, for the particular places they are used for the zigzag cross arm. This is used for both transmission as well as for the distribution purpose. If the dead zone, wherever the end point, wherever the cross section is there, the particular places, the conductor is not maintained for the same spacing. For the particular places, they are used for the zigzag cross arms. Here they are fitting for the insulator. They can use it here, or in this the particular places are here. This is used for single as well as for double circuit. And at the top of the insulator view, they are laid for the conductors. These are the various types of cross arms. That is, it is classified for 4 types: MS channel cross arm, U-shaped cross arm, V-shaped, and then zigzag cross arm. These the MS channel cross arms is used for the distribution purpose. That is single phase 240 volt and then 3-phase 440 volt. And the U-shaped cross arms is used for distribution as well as for the transmission purpose. V-shaped cross arms is particularly used for transmission line, that is 11 kV and then 33 kV. The zigzag cross-arms where they are used, means wherever the dead zone, wherever the cross section is there, at the particular places they are used for zigzag cross-arms. That is used for both transmission as well as for the distribution purpose. And the next one, pole guide. The pole guide, the another name is nothing but guy wire or stay wire or pole bow. Pole bow. Actually, this is the supporting structure, that is the pole, that is PSCC pole or RCC pole or steel pole. Here, the 1 feet below, they are fixed for the cross arms with the help of bolt net. Here, they are fixing for the insulator, and at the top of the insulator, they are taken for the conductors. That is in over a transmission line, a distribution line, the conductor they are used for ACSR conductor, that is aluminum conductor, steel reinforced. Unfortunately, if the conductors are close to each other, within a fraction of a second, the voltage is dropped, the current is increased, and that it will be flows through the ground through the body of the insulator. Unfortunately, if any the current is leakage, here at the every third pole or every fifth pole, they are used for the stay wire or guy wire. Here in this, the half of the portion they will be fixed for the insulator material, that is the porcelain material, the pole bow or pole guy. That is, suppose if the current is flowing in the body of the same material, that is ACSR conductor material, it is not flows through this in this the remaining part. That's why they are used for the pole bow or pole guy. This is the necessity of pole guys. In over a transmission line using pole, it experienced with different pulls. Generally, the intermediate pole will experience on either side. It should be tilted at an angle. At the time of erection, there is no problem. After a 1 month or 2 months, the end of the pole, it is not in the same position. Based upon the weight of the conductor, either it should be tilted either leftwards or rightward. If it tilted leftward means that is the sag occurred is more. The sag occur is more. Due to that, if the small wind pressure is there, the conductors are close to each other. That is the short circuit is appeared. And one more thing, the conductors are short circuited each other. For the particular places, the conductor is considered for the rough surface. Due to that, the voltage drop is more, in effect is increases, and the corona is also more. Suppose if the pole is tilted at left hand side, now the conductor is fully stretched like a rubber band. The conductor is cut into 2 or 3 pieces. To avoid that one, they are used for the pole guy or the stay wire. And it is very necessary to provide an additional arrangement to neutralize these pulls, and the such arrangement is called as the pole guy or pole bow. Some of the places where the area it should be always the water is the stagnant. For the particular places, they are used for 1 stay wire or the 2 stay wire or 2 stay bow based upon the condition. Suppose it is not withstand means for the particular places, additional they are supporting used for the one more pole. This is the same RCC pole. RCC pole, the same RCC pole they are used for the supporting. It should not be tilted at an angle, any position. Initially at the time of erection, the tilt at an angle of 90 degree. After that, the position it should be changed, either 95 or 100, 110, so on, etc. For that purpose, they are used for the pole guys. And next one, the overhead line insulator. That is the definition of the insulator. That is, insulators are fitting used to secure power conductor to the supporting structure. Generally, the insulator, the main function is it should not clash to the conductor. Actually, here in this the pole, that is, we can take either wooden pole or steel pole, RCC or PSCC pole. Here the cross arms is there. This is the cross arms, the material used for the iron material. Without insulator, the conductors are laid on the cross arms means it should be short circuited. To avoid that one, we are used for the insulator. That's the fitted in the cross arms with the help of bolt net. The top of the insulator, they are taken for the conductor. It should be secure the power conductor and it should not short circuited. And one more thing, This insulator, it should be maintained from the conductor, it will be maintained for the same distance from one pole to another pole, or one point to the another point, that is starting position to the ending point. This line conductors the metallic part of supporting structure, and this the insulator gives the mechanical support to the conductor. It can withstand for the any temperature level, and it can withstand for the any wind pressure. This is the definition of the insulator. And what is the purpose of the insulator or necessity of the insulator? The insulator which avoids the flow of current from the conductor to the earth. Already we have discussed in the definition itself. And generally in the overhead transmission line, the conductor should be supported on the poles or tower in such a way that the current from the line do not flow to the earth. If puncture or the flashover is carried in the overhead transmission line, it flows through the ground, through the body of the insulator. At that time, the insulator should be protected without the short circuited to any living organism or any human being, the surrounding of the supporting structures. That is the main purpose or the function of the insulators. And the requirement of the insulator are the characteristics of insulator or properties of overhead line insulator. Before selecting the insulator, what are the parameters we need to do? The first one, high mechanical strength. In order to withstand the conductor weight and the wind load, etc. In overhead transmission line, there are two weight is there. One is for the conductor weight is presented on the vertical downwards W, and the wind weight is there, that is represent for the WW. It is affected for horizontal. It can be withstand for so both the weight, that is should be the insulator should be withstand for the high mechanical strength, that is it can be withstand for weight of the conductor as well as for the wind velocity. And the second one, free from the internal impurities and cracks. We are choosing the insulator if the small amount of the air gap is there, that is the insulator are classified for pin type insulator, suspension another name is called as disc type insulator, strain type insulator, shackle type insulator. Based upon the operating voltage, we are chosen which insulator is required. For shackle and then strain type insulator is used for the distribution purpose. The pin type insulator and disc type insulator is used for transmission purpose. This the pin type insulator is used up to 33 kV. Beyond 33 kV, economically it is not satisfied, and the size is also increased, the weight is also increased. At that time, we are used for suspension or disc type insulator. Suspension or disc type insulator. Actually, the material they are used for the porcelain material or tungsten glass coated material. Previously, they are used for the porcelain material, but recently, for all the transmission line, they are used for the tungsten glass material. Here, they are coated with the help of the casing. They are molded. The top of the molding, they are applied for the varnishes. Here, at the time of molding, it is, for example, you can take the disc type insulator. At the time of the molding, suppose any the small air bubble or air gap is occurred. Air bubble or air gap is occurred due to the puncture or the flashover, the insulator or the crack appeared. That is, it is not observed with our naked eyes. But in the overhead transmission line, in the climate condition, some of the time rainy season, the water particle is observed. In the moisture particle, the water is observed. At the time, the voltage drop is increased and the short circuit is appeared. To avoid that one, before choosing the insulator, we need to check it. It should be free from the internal impurities and then crack. We are selecting the insulator. It should not observe for the moisture particle, gas, alkalines, so on, etc. And the next the requirement is it should not observe any moisture or water particle. If the moisture and then the water particle is observed, means short circuit is taken place and the voltage drop is also increased. And for example, you can take this is the n number of the supporting structure is there. we are taken the example is three conductors, that is R phase, Y phase, another one is for the B phase. For example, you can take the 11 kV transmission, 11 kV distribution line or 11 kV secondary transmission line. Now here all the insulator should be good condition, there is no problem. Suppose here the any one of the insulator is the crack, it should observe for the moisture particle. Due to the observe of the moisture particle or water particle, the voltage is drop. Here I square R losses, some amount of the drop is there. Here the flow of the operating voltage is 11.92 kV, that is 0.8 kV is the line losses. It is 0.08 kV in terms of line losses. Here the voltage drop is more. What about the next level? For example, you can take that is 10.8 kV, that is 1.2 kV in terms of losses. This effect is presented up to the end of the line or up to the end of the consumer. For that purpose, we need to take the very much care before selecting the insulator. That is, it should not observe for any moisture and the water particle. And it can be visioned for large variation in temperature. That is, large variation in the temperature means it can be visioned for the atmospheric temperature. Throughout the year 365 days, the climate condition is not same. Some of the days the temperature is 27 degrees centigrade and 30, 32. Some of the time it goes to the 40 to 43 degrees centigrade. We are selecting the insulator, that material, it can be visioned for the large variation in the temperature. That is in the open atmospheric air temperature. And the next one, it should be free from the gases, fluids in the atmosphere. That is, it should not observe for the water particle, moisture particle. It should not observe for gases, the fluids in the atmosphere. For looking, the insulator we are selecting, it should be the good looking space, and the lifespan it should be more. The lifespan it should be more. That is the long lifespan. It should be either 50 years or 70 years or 100 years. And the cost is also less. Based upon the material, the cost it should be different. These are the various requirements of the insulator or characteristics of insulator. Otherwise, it is represent for the properties of overhead transmission line. These are the various properties of the overhead transmission line. The main thing, we are choosing the insulator, it can be visioned for high mechanical strength. That is two parameters. One is for the weight of the conductor, another one is for the wind velocity, and it should not observe for moisture particle, gases, the fluids and alkalines in the atmosphere. And we are choosing the insulator free from the internal impurities and cracks, and we stand for the any temperature level in the open atmosphere. For looking, it should be for good shape, and lifespan it should be more. These are the various properties or requirement of the insulator. And the insulator materials, generally the insulator materials are classified for four types. The one is porcelain material, toughened glass, statite, composite insulator or non-ceramic insulator. That is, the first one is the porcelain insulator. The most commonly the used material in the overhead transmission line is the porcelain material. It consists of 20% of silica, 20% of silica plus 30% of field span, plus 50% of clay. In the porcelain material, the material they are used is called as 20% of silica and 30% of field span and 50% of the clay. And the porcelain produced by the firing at the high temperature, a mixture of kaolin, field span and then quartz. These are the materials they are used before molding of the material. That is, the maximum 50% the clay is used, and the varnish, the coating and the material they are used for the field span and then silica. And the material, the porcelain material is affected very less in the atmospheric condition. That is based upon the change in temperature level. the effect is very, very less, and the dielectric strength is the good. That is, the dielectric strength in the porcelain material is 120 to 280 kV per centimeter. The dielectric strength in the porcelain material is 120 to 280 kV per material, and it should not observe for the moisture particle. It should not observe for the alkaline, the gases, etc. And the mechanical strength is also good. The less trouble from the leakages. This is the material used in the porcelain material, but maximum they are used for the distribution purpose. Another one, toughened glass material. Toughened glass material. What are the drawback in the porcelain material that overcome in the toughened glass material? The drawback in the porcelain material is, once we are coating in the insulator, that is, this is the shape of the pin type insulator. This is the shape of the pin type insulator, and this is the shape of the disc type or suspension type insulator. Under molding, if any air bubbles or any the crack is there, it is not visible with our naked eyes. But in the toughened glass material, clearly it is visible with our naked eyes. This is the advantages of the toughened glass material. In toughened glass material, the dielectric strength is good, that is 1200 kV per centimeter. In porcelain material, the dielectric strength is 120 to 280 kV per centimeter. That is 120 to 280 kV per centimeter. But in toughened glasses, that is the dielectric strength is 1200 kV per centimeter. It is used for the transmission line, that is 400 and then 765 kV length. At present, nowadays they are used for 220 kV, 400 and then 765 kV transmission. And the mechanical strength is good comparing to the remaining all type of material. And moisture, it is not observed that toughened glass material, because they are used for the glass coated material, and it can be withstand for the any temperature level, but the cost is high comparing to the porcelain material. And the next one is statite material. Statite material, and this the material consists of magnesium oxide, and the silica material consists of this magnesium oxide, plus they are used for the silica. Here the tensile strength is good, and it can be withstand for the temperature level. But comparing to these two, the porcelain and then toughened material, the mechanical strength is somewhat less. This is the drawback of the statite material. And the last one is composite insulator or non-ceramic insulator. Here the material they are used for the polymer material. The polymeric material is called as ethanoic propylene rubber, that is EPR, ethanoic propylene rubber, and another one is PTFE, that is polytetrafluoroethylene. The next one is silicon rubber. These are the material used for composite insulator, otherwise the non-ceramic insulator. Here, once you are used for the rubber coating the material, is observed for the moisture particle, the little bit of the moisture particle observed. But comparing to these, the four types of insulator, that is the porcelain, toughened glass, statite, another one is for the composite material. These two they are preferred for this one. And previous days they are used for the porcelain material, but recent days they are preferred for the only toughened glass material. For 220 kV transmission line, 400 and then 765 kV transmission line, the material they are used for the toughened glass material. Why they are used the toughened glass material means, if at the time of erecting the transmission line and then distribution line, the toughened glass material just we are taken with our naked eyes, it is clearly visible. That is, the air bubbles or any the crack is appeared at the time itself. We are not erecting those the insulator. We are not taken those insulators. Once we are erecting means after a 6 month or after 3 months, due to the puncture and the flashover in the transmission line, the insulator get failure or the insulator, the crack is appeared. It is observed for the moisture particle, water particle, gasoline in the atmosphere. Due to that, the voltage drop is increased and the short circuit is appeared. To avoid those one, we are preferred for the toughened glass material. And the types of insulator based upon the operating voltage, it is classified for 4 types of insulator: pin type insulator, suspension type insulator, strain type insulator, shackle type insulator. This elaborately we will discuss in the next class. In this today class, we are discussed about factors influencing the selection of line supports and what is the cross-arms, necessity of the cross-arms and various types of cross-arm. What is the pole guy or pole bow? What is the need of the pole guy and overhead line insulator? The purpose and the necessity and the requirements of the insulator, that is represented called as properties of the insulator and insulator materials.